Okay, we should all be on this page here. And we're going to go through this whole page today, and I'm just going to give you a warning now. It's a lot of vocab today. So we're going to be going over a lot of these terms that we're going to be seeing in the coming days. We're not going to maybe be doing a ton right now with like actually finding missing measurements or maybe like finding things like we did yesterday, like vectors and scale factors. We're more so going to be focusing on these different terms that we're going to see as we move forward into actually solving missing measurements. But we need to talk about what they are first so that you kind of know what's going on in a picture when you start to see these vocab words show up in directions, or if I'm talking about something and I use any of these words, I want you to know what I mean. So we're going to go over a lot of this here. Now I kind of have it broken apart. There's like 3 circles. So we're going to do a couple of vocab words, draw some examples of those vocab words specifically on the circle. Then we'll move on to the next one. Because if I put it all on one circle, there'd be a lot. And it would get really confusing really fast because of all the letters and stuff that we see. Okay, so let's just start off by going over again what a circle is, which we already know because we've talked about circles before. We know what a circle looks like. We know some parts of a circle already. And we talked about this yesterday too, but the definition of a circle says that it is the set of points equidistant, which is like a really fancy way of saying equal distance. That would also be known as like what your radius is from a center point. So if you remember yesterday when we talked about size of a circle, when we were dealing with scale factor and trying to figure out the dilation scale factor that they used, we were using the radius to do that. So remember what a radius looks like is it's measuring like the distance from the center of the circle to the edge of the circle, that length, like all those points. If the radius was 5 centimeters, let's just say, then any point that is 5 centimeters away from the circle would be on the edge of the circle, is really what that definition means. Okay. Now, some of these things in the first kind of chunk we've talked about, we kind of know what a center is. We should know what circumference is because we've had to talk about that before. And we should know what a radius and a diameter is. Okay, but chord is maybe this new word that we haven't seen before or talked about. So let's go over the stuff that we know, and then we'll get into this new one. So the center is pretty simple, that it's just used to label a circle. And we saw this even yesterday when they were talking about the center from this circle went to the center to this circle. It was a coordinate. Or when I was labeling a circle yesterday when we were going over talking about those transformations, I used that symbol for a circle, which is just a small little circle, and then there'd be like a capital letter next to it. So that would just read as circle A. So on my picture over here, if I wanted to name this circle circle A, I would just put an A next to that point in the middle. Since it's a point, that's why we're using a capital letter. We always use a capital letter to name a point. So the same thing's going to happen here on a circle. All right, now circumference is the next one. I'm going down on the left-hand side here. So circumference, we've talked about how to solve for circumference in the past, but what was circumference? Anyone remember what circumference is measuring? Not area of a circle. Because we had the formula over there, 2 pi r or pi times diameter. The outside, like edge only, right? So it's kind of like perimeter, but a circle doesn't have sides, doesn't have straight polygon sides like a square or a rectangle does. So we had circumference instead because we talked about how it relates to pi and all of that. So circumference is the outside edge of the circle, like how long it is. So I'm just going to rephrase that as it's the distance around a circle. Just like perimeter would be the distance around a shape. So if I were to maybe cut that circle at a certain point and then just have it lay flat, I would be measuring that distance. That would be my circumference length there. Okay. Now we should know what a radius is, but how would you guys describe a radius to someone else who's never heard of it before?
Half of the diameter.
What if they don't know what a diameter is? And I'm not disagreeing with you. It is half a diameter. But if someone doesn't know what a radius is, they may not know what a diameter is.
Half the length of going across the circle.
Okay. What were you going to say, Mason?
Like for the radius, you could say like
Halfway or like halfway from the edge to the middle through your circle. Okay. All right. So let's talk about how we would maybe write this out in words. I think you guys are all right. You're going from the edge of the circle to the middle of the circle. It's halfway across the full distance there. Okay. But the key thing is that you're going from the center to the edge. We have to have that center in there. So I'm going to say this is a segment from center to the edge. Okay, let's draw in some examples of a radius. How many radii do you see in my picture right now? 3. When we name them, we want to start from the center and go out to the edge. So how would you name the 3 radii that you see? Okay, A, B, AC, and AD. Good. And when you're labeling them, it's just a segment. So our segment notation above the top is just that line, no arrows. Okay, it's just the line segment. Now, AC and AD, we know some stuff about circles. If I were to put those together, what is it making? A diameter. So maybe let's write ourselves a little note about that. These 2 things together make a diameter. Okay, and that leads me to my next definition. Over here now, to the right, let's go up to a diameter. So you guys were able to kind of work your way through how you would explain what a radius is. How would you explain to somebody what a diameter is?
A line going from edge to edge.
A line going from edge to edge. Okay. Does it have to do something special though? Because like I could go like this, edge to edge. Is that a diameter?
like how
Going through the center.
Has to go through the center, right? We have to clarify that when you're talking about a diameter, it does go edge to edge, but it must pass through the center. It has to do that or it's not considered a diameter anymore. So I'm going to write that down here. It is a segment, just like a radius was. Segment with endpoints on the circle. And goes through the center. When you name a diameter, you just use the endpoints. So I would just call the diameter here either CD or DC. I don't have to say CAD. We don't use 3 points when we're naming a line segment. We just use 2. So I would just use one endpoint and the other endpoint. So to name this diameter, you could say CD. Or you could switch it and say DC. The order does not really matter when you're naming a diameter. Okay, now I'm going to back up just a second because when you were giving me the definition of a diameter, I showed you that example of edge to edge and it didn't go through the center. I'm going to draw that back up in here, or at least something like it. We'll call this E, and we'll call that point F. That's not a diameter. Okay, this is this word that we've never seen or heard before. And maybe you've heard of this word before in another class. I don't know. But this would be called a chord. A chord is like a diameter in that it goes from edge to edge of a circle, but it does not have to pass through the center. So a chord, the definition here is that it's still a segment with endpoints on the circle. But that's it. There's no and goes through the center when we're talking about chords. Now, it could go through the center. So the diameter that we had, this is actually a special type of chord. If it does go through the center, it's still a chord. So all diameters are considered chords. But not all chords could be considered diameters because they may not go through the center. If it is going through the center like this, like CD is, this is the longest chord possible on your circle. That would have maximum length. Okay, diameters would always have maximum length because you're going from one edge to the other edge through the center. So that's the biggest distance that you're going to have on a circle. These other chords that I maybe draw in here, they don't have to be as long. In fact, I could have even put E and F closer together on my edge of my circle and still call it a chord. It would just maybe be really small, but all of those would be possibilities. It could also be really close to diameter and maybe just above or just below that center point. But if it doesn't go through the center, it's not considered a diameter. Do we have any questions on those vocab words so far? Hopefully most of that stuff wasn't like brand new because you've seen most of that other than the chord. The chord is the new one. Now, all of these, I'm just going to highlight really quick. All of these words that I just went through are going to connect to this circle. So if you have like a highlighter and you want to maybe do what I'm doing there, you don't have to. But if you're someone who likes to be able to look back at your notes, and if you're looking for a specific example, we're going to move on to the next circle now. And so I want you to know all of those vocab words that we just talked about, examples can be found on that first circle. All right, any questions on any of that before we move on? Okay, so I'm going to move down to the next couple of words in our next circle here. So on either side of the circle, it says tangent line and it says secant line. I want to talk about what these are and how they're different from each other. They're both lines. Okay, so lines we know go on forever in both directions. They have arrows on them. They have points on them that we could use to name the line. So that's what we're going to be looking for here when we're drawing these. But they are a little bit different from each other. A tangent does something that a secant does not do, and a secant does something that a tangent does not do. Okay, a tangent line, the definition of this is it is a line that hits a circle at exactly one point. When you draw in a tangent, in order for it to only hit a circle at one point, where do you think it needs to be? On the outside. It can't go through the circle. Okay? So it'd be like, almost think about like if you had a basketball. Okay, I know basketball's not a true circle, it's a sphere. But if I lay the basketball down on the ground or on the gym floor and I just let it sit there, where the floor hits the basketball, that's a point of tangency because it hits it at one point on the outside of the shape. So that's kind of what we're talking about here. If I had a circle and I were to like lay it down here on my podium, or I were to like lay the circle standing upright, or like a coin. Think about like a penny or a nickel or something. All of those are circular. If you've ever had a coin stand upright on your table, that point where the table hits the coin would be a tangent line there because it only hits at one point on the outside edge. It doesn't go through, the table doesn't go through the coin or anything like that. It just hits the edge. So when I draw this on here, I need it to be on the outside of the circle. It's going to hit the circle at one point. So I'm just going to draw a point on the circle, and then I'm going to have a line kind of coming off on both edges here. So it looks like that straight line. And then let's just call this point where it hits the circle G. And then I'm going to put another point on my line somewhere, H. And I need that because I want to name this. So I would name this line GH, or you could say HG. Again, the order doesn't really matter. But remember, your symbol for a line is the line segment with the double arrows on it. So make sure you have that. The other thing you might want to just add to your picture is G, this point here, would be called the point of tangency, which is just saying this is where the line hits the circle at one point. It's at that specific spot. So in a problem in the future, if they're describing a situation to you or they're talking about something and they say point of tangency, that's what they mean. It's the point on the edge of the circle that this line on the outside is going through. So a tangent line doesn't go through the circle. It's on the outside of the circle, hits it one time. A secant line is a little bit different. Okay, a secant does go through the circle, but it has to hit the circle twice. So let's write that out. We're going to say this is a line that hits a circle twice. And I'm just going to draw one in. It does not really matter what direction you guys put it in here. It can go really any way. It could go through the center if we wanted it to go through the center. We'll call this point I, and we'll call this point J. And just like we did with a tangent line, when we're naming the secant line, you just use 2 points. So I and J or JI, it doesn't matter the order. And you put the line with the arrows above it. So that would be a secant line. So tangents hit the outside, secants have to go through the circle and hit it twice. Questions on the difference between those two? Okay, so like before, I'm going to go ahead and just kind of highlight these two words are going to come from this circle here. Okay, and we've got one more circle here on our kind of vocab area before we do some examples at the bottom. And then we've got a couple more vocab words. So last little piece here talks a lot about things called arcs. Okay, so let's just talk about what a general arc is, and then we'll get into like the specific types. So a general arc is just a piece of the circumference. So remember, circumference is like all the way around a circle. An arc would just be, I only want this portion of the circle. So if I have a pizza and I take out a slice of pizza and I want my crust length, that would be an arc because it's just a portion of the entire circle that I started with. Now with that, there are different types of arcs. We have something called a major arc, we have a minor arc, and we have something called a semicircle. We probably already know what a semicircle is. At least we know what it looks like because we've seen them before when we were dealing with like area and circumference and all that. But the minor and major arcs are new to us. So let's talk about what they are. When you're measuring an arc, it's all going to be in degrees. Now, do you guys know how many degrees are in a circle total? 360. If you go all the way around in a circle, you travel 360 degrees. So when I'm looking at arcs, they can be anywhere from 1 degree up to 360 degrees. Okay? I mean, 0 degrees would just mean you don't move. You stay in the same location. So when I'm talking about these different types, they have like parameters on them as to what would constitute it to be classified as each one. If something is going to be called a major arc, this would be an arc that is greater than 180 degrees. And I'm just going to put down here, this uses 3 points. You use 3 points to name a major arc is what that means. After I go through the definitions, I'll throw some points on our circle and then we'll actually name some of these arcs so you have an idea of what that looks like. So a major arc would be something greater than 180. Anyone have a guess what you think a minor arc means then?
Less than 180.
Less than 180. If you want to name a minor arc, you only need 2 letters. So I'll just say 2 points. We'll use 2 points to name a minor arc. A semicircle is another type of arc, but what do you think this one needs to be? What would be half?
180.
180. So a semicircle is an arc that equals 180. Okay, I'm going to add some points to my circle here. The first thing I'm going to do actually is draw in a diameter. Let's start by naming the major arc. So a major arc would be something greater than 180, and we use 3 points. Now, I don't have any numbers on here, so we just kind of have to use our best judgment as to thinking we think that this would be over 180. We know what a semicircle would be, and that's why I drew in that diameter, because that's going to kind of give us our halfway point. So I would need something that goes over that. So if I were to start at L and travel around my circle, and maybe I hit K, I would want to go beyond M because that wouldn't be greater than 180. That would be an example of a semicircle. So if I go LK, I would want to maybe go all the way to N for a major arc. So I could call that LKN. So I'll do that over here, LKN. And when you're labeling an arc, you're going to draw like a tiny little arc above those letters. Can you guys give me an arc starting with letter M? Still major. MNK would work. MLN would also be a major arc, so you could have gone like that way with it too if you wanted. But you need 3 letters to name a major arc, and when you're actually starting to find measurements, which we'll be doing in the next couple of days, then your number should always be bigger than 180. So if you name something where the name is giving you 3 letters and you put down something like 45 degrees, that should almost, for you, be a way to be like, something about that is wrong. I maybe went the wrong direction or something. When you're looking at arcs, you want to make sure you follow the order of their letters to kind of trace their pathway around the circle. Okay? Now, a minor arc is only 2 points and it's less than 180. Anyone see an example they think would work for a minor arc? MN works. And we do the same thing, 2 letters, and we put like a little arc over them. Do you guys see another one?
Okay.
Okay. You could say MK if you want. We'll add that here too. Those are all good examples. Again, order doesn't really matter. I could have flipped any of those letters around, N, M, K, L, K, M, and those would also be minor arcs. But those would all be less than 180 degrees, it looks like. Now, semicircle is an arc that is 180. Those are formed by diameters, which means semicircles can actually be named 2 ways. You can name it with 2 letters, just using the endpoints of your diameter, or you could use 3 letters if you wanted to. If I only wanted to use the endpoints of my diameter for a semicircle in this picture, what would I say? ML. If I wanted to use 3 letters though, anyone have an idea what that might look like? LNM would work. Or I could have included MKL if I wanted to. Or again, I could flip the order. I could start at L and go towards M and use 3 letters that way too. So there's more than just those possibilities. It's just giving you an idea of how that maybe would look. Okay, all of these vocab words then are attached to this circle. All right. That was a lot of vocab. Do we have any questions on anything I've talked about so far? So at the bottom of your page, there's really nothing about like solving for missing measurements. What they're doing at the bottom is they're describing something that's happening to a circle. And we need to just draw a picture that reflects this. So I'm actually just going to give you like maybe 2 minutes here. I want you to read through those 3, all of them, and do what you can with drawing. See what you can put on the circles by yourself. Label everything that they talk about. All right, let's start working through these. Now, your picture may look different than mine, and that's okay, as long as we're getting the same idea across. Let's start with the first one. First, what should I name this circle? What letter should go by the center point?
M.
Good, M. Okay, it says secant line AB intersects circle M at points A and B. What does a secant line look like? All the way through, and it hits the circle how many times? Twice. So I don't care where you guys put it. I'm just going to put mine right here. Should have arrows on it because it is a line. And these 2 points where it hits the circle should be labeled what? There you go. If you have your secant line somewhere else, that's fine. Okay, let's go on to B. What would we name this circle? R. Okay, this one says secant line MN intersects tangent line TM on circle R. So we just talked about secants. We know that that goes through the circle. I'm just going to draw it the same way. What letter should I put on my secant here? M and N. Okay, so that's my secant. Now let's talk about the tangent line. Where should I draw that?
On the outside.
On the outside. And what letter should it go through? M. And how do we know that it's going to share a point there? How do you know it shares that?
Have an M in there.
Their names, right? They both have an M in their names. And it also says they intersect. Intersect means they would cross. Okay? So from M, I need to draw a tangent line. Now remember, a tangent line is only on the outside of the circle, like that. What other point should I put on that line, though? T. Does it matter where I go? No. I'm just going to put it up here. But you could have put it down here if you wanted to, or you can put it here. It doesn't really matter. All right, let's go to C. How are we naming this circle? M. What should I draw? What's the diameter look like? Does it have arrows?
No.
So just point to point. How are we naming that? AB. Okay, what else do I need? Another tangent line. Where should it go? Off of B. And what else should go on that line? G. And again, it doesn't matter where you put it, so let's put it down here this time. Okay. As long as your pictures look similar to that, you should be fine. They don't have to be identical. All right, I'm going to get you guys your homework.